Okay, this is the last review FRQ for the rate in, rate out type. This is question number 1 from 2018. Please make sure you've already done it before you watch the video. It is talking about the escalator and the amount of people that enter and exit the escalator. So it says that people enter a line for an escalator at a rate modeled by the function r given below. So notice that r is the rate at which people enter a line. So we would call this the rate in. So rate is measured in people per second and t is measured in seconds. And then it says as people get on the escalator, they exit the line at a constant rate of 0.7 persons per second. So we have a couple things going on here. We have the line for the escalator, and then we have people getting on the escalator. So this is the rate at which people enter the line to get on the escalator. And then this 0.7 is the rate at which people get on the escalator. In other words, it's the rate at which people get out of the line because they are no longer in line if they're on the escalator. So we would say that our rate in is r of t and our rate out is just 0.7. So 0.7 is a rate. Keep that in mind, that's important. And then it tells us there are 20 people in line at t equals 0. So there is our initial condition here. Part A, it says how many people enter the line for the escalator during the time interval 0 to 300. So how many people enter the line? Well, that's just going to be the integral of our rate in. So we would say the integral from 0 to 300 of r of t dt. Typing that into our calculator, we would say 270, and the units on that would be people, but you don't have to put units because it didn't indicate that. You're going to get 1 point for the correct integral expression, so 1 point for this guy, and then 1 point for the correct answer. Okay, for part B it says during the time interval 0 to 300, there are always people in the line for the escalator. How many people are in line at t equals 300? So this is equivalent to a position problem. How many people are in line? How many bananas are there on the shelves? It's a position thing. So we need to know how many people we started with. So we started with 20 people. So we'd say 20 plus the integral from 0 to 300 r of t dt. Now why is that? This is what we started with plus how many people were added, because r of t represents the rate in. The integral of r of t represents how many people were added. And then we need to subtract from that the amount of people that were taken away. Well, because 0.7 represents the rate out, we would say the integral from 0 to 300 of 0.7 dt. So again, how many people we started with, how many people were added, how many people were taken away. And then we're just typing this into our calculator, so we end up with 80, and that would be people. So 1 point for considering the rate out. In other words, knowing that you have an integral of 0.7 from 0 to 300, you're going to get 1 point considering that. Now there's another way of doing that. You could have just said 0.7 times 300 and gotten that value too. So if you just said minus 0.7 times 300, that would also give you your 1 point for considering the rate out. And then you're going to get 1 point for your final answer of 80. For part C, it says for t greater than 300, what is the first time that there are no people in the line for the escalator? So the thing that I notice here is that this is saying for t greater than 300. Well, looking at the function r, we can see for the interval t greater than 300 that r is 0. In other words, the rate in is 0. In other words, there are no people getting on the escalator after t is equal to 300. So what is the first time that there are no people in line for the escalator? So that's saying, when is the amount of people equal to 0? Well, remember the equation for the amount of people. The amount of people in line is the amount we started with plus the amount that were added minus the amount that were taken away. So we could go back to this equation here, but we're not going to put 300 here. We could use this. But we've got an issue here because r of t If we just use the integral from 0 to something of r of t and it's greater than 300, we have a piecewise here, so our function changes. So what I'm going to do in this problem in part C is I'm going to use a different initial condition. Instead of using an initial condition of 20 when t equals 0, I'm going to use the initial condition of 80 people when t equals 300. So when t equals 300, we started with 80 people. And then from there, we would say we added the amount of people added to the line is going to be the integral of the rate in. Well, because we're talking about the integral from 300 now, because our initial condition was the time 300, there's nobody being added, so we don't have to consider that. So we'd say 80 minus the amount of people out. So 80 minus the integral from 300 to t of 0.7 dx. So again, this is the amount of people that we started with at t equals 300. We found that in part B. And then we subtract the amount of people that were taken away over that time interval. Now the question is, what is the time? And that's why there's a variable here of time, and that's why I had to change this to x. We want to know when the amount of people here is equal to 0, because it says when is there no people in line. From here, we would solve this equation analytically. So we're going to add the integral to both sides, and then we'll go ahead and take the antiderivative of this guy. The antiderivative of 0.7 is 0.7x, and then evaluated from 300 to t. So we'd say 0.7 times t minus 0.7 times 300. And then from there we can simplify it and then solve for t. And we end up with t equals 414.286, and the units would be seconds on that if it asked. So point values on this, you're going to get 1 point for your answer, and and that is it, 1 point for your answer. So that was a lot of work for 1 point. This one I know is probably a little bit confusing to you, but hopefully after I explained it that helped out. If you have any questions on it, please ask me. For part D, it says for 0 to 300. So now we're back in the realm of dealing with r of t, this part of the equation, because we're looking from 0 to 300. At what time is the number of people in line a minimum? So we are looking for an absolute minimum here. Well, how do we find absolute minimum? We need to consider the overall rate. And because the rate is broken up into a rate in and a rate out, we need an overall rate. So the first thing I'm going to do is define the amount of people. I'm going to say let A equal the amount of people in line. Well, remember, the amount of people in line is the initial condition of 20 plus the integral from 0 to t of r of x dx minus the integral from 0 to t of 0.7 dx. Again, how many people we started with at t equals 0 plus the amount added minus the amount taken away. So this is the amount, and because I'm looking for the minimum amount, we're going to take the derivative of this. Now the derivative of 20 is 0, so that's easy enough. The derivative of the integral of r of x dx from 0 to t is just going to be r of t, and the integral from the derivative of the integral of 0.7 from 0 to t is just 0.7. Again, going through the motions here, if I plug in, taking the derivative, plug in t, so I get r of t, times the derivative of t, which is 1, minus plug in 0, so r of 0, times the derivative of 0, so all of that, which is 0, all of that would cancel out, so you're just left with r of t. And then plugging in t to this equation, when I'm taking the derivative, there is no t to plug into, or so no x to plug into, so we're just left with 0.7 as our derivative there. From there, we're going to find our critical point. So since I have my overall rate, I'm going to set that equal to 0. And then I should have this saved in my y1. I'm going to put 0.7 in my y2. And then by adding 0.7, we notice that r of t minus 0.7 equals 0 is the same as 0.7 equals r of t, which means we can look for the intersection of these two things. So if this is y1 and this is y2, the intersections are 33.013 and 166.575. So there's 2 points of intersection there. Remember, our other critical points are when the derivative does not exist. Well, the derivative always exists because r of t always exists in that domain, and then this function, the rate out, always exists. So the derivative always exists. And then our endpoints are our other critical points. So we have critical points of 0, 33, 166, and 300. Now, because I want the absolute minimum, we are going to take all those critical points and plug them back into our amount function to figure that out. So we would say a of 0. If I plug that in, I'd get 20 plus integral from 0 to 0 minus integral from 0 to 0, but ultimately we get 20, and we knew that anyways because when t equals 0, there was 20 people in line. For t equals 33, again, you can plug that in, and that's what I'm doing here. I'm just plugging in 33.013 to both of these t's and evaluating both of these integrals and then coming up with that answer. So we end up with 3.803. And then when t equals 166.575, plug that in, and you're going to end up with 158.070. And then the last one, when I plug in 300, well, I already did that work in a previous part. That was 80 people. So the question is, at what time is the number of people in line a minimum? Well, we can see that the minimum number of people is 3.8 people. The time that took place is 33.013 seconds. So the minimum occurs when t equals 33.013. The next question, it says, to the nearest whole number, find the number of people in line at this time. Well, the number of people in line at that time is going to be 4 because that's closest to 3.803. So those are my two answers there. You would get 1 point for considering r of t minus 0.7 equals 0. So this line here, right? If you got to there, you got 1 point. You get 1 point for using your critical points, so identifying all your critical points. And then you're going to get 1 point for your answers and 1 point for your justification. So if you had both of these answers, that's the 1 point for the answer, and your justification is evaluating all the amounts at the critical points. So that wraps up our last question for the type 5 rate in, rate out problems. Go ahead and grade yourself on this, and then input your answer or input your scores for the last 2 FRQs into Socrative. And then our next set of problems, our next review is going to be on differential equations.